Good morning and welcome to this webinar. In behalf of the whole consortium, I welcome you all to this face-to-face event and then everyone in Zoom who has joined. And we have several presentations, and I start with the first one to a little bit explain you what is our project. Right. So I'm the coordinator of the project, and I come from a VTT. And the technical facts about the project is that this is Open Innovation Testbed project. So it means that that we are developing materials and solutions for industry to replace fossil resources with a sustainable and cost-competitive bio-based materials. And how we do this is that we have pilot lines in several countries in a large-scale facilities which can be used to make demonstrators. We have altogether 27 partners, and we make during the project with our early adapters demonstrators in several industrial areas. As a total, the Open Innovation Tested budget is over 60 million euros, and it's about 4-year project. And now our last year is starting next month. So we are more disseminating the results and showing what we have already achieved. The project was planned to really target for solutions that could help to have solutions that would be fitting to the circular economy. And our pilots, what we use in this Open Innovation Testbed, they are targeting for scaling up the solutions. Of course, we need a little bit research before that, but mainly we target to have enough material to have large-scale trials, and then also demonstrators that can be tested in an end testing. Okay, thank you. And the bigger target is really to use bio-based materials that would create equal or outperformed fossil counterparts in different products. And for that, we need different kind of pilot facilities. We need, of course, materials that we produce, novel materials, but besides that, we need pilot lines where we can formulate and mix these materials with the other materials, and then finally to process them to the final end products. And really, we focus on things that we are scaling up, the nano-enabled biomaterials and processes, and we are targeting in all cases from the TRL level 4 to 5, that there is already some kind of proof of concept in a laboratory scale. And then we are targeting to make demo materials so that we can do the end product testing. And we are targeting for different industrial areas. So one of our main application area is packaging. So we have there four demo cases which are targeted to be recyclable or reusable in a circular economy. Then we have 3 demo cases in energy and transport sectors. Two of them are targeted for plastic parts in the cars, and then we have one interesting application about ultra capacitors. And similar technologies what we use for making packaging or these plastic parts for cars can be used also to make consumer products. And in general, we target these products to be recyclable, and then that they would have so little as possible that sort of fossil-based raw materials. So this is a big project, collaborative network with 27 partners. And in this slide, you see all our partners, and 16 first ones are the pilot line and service providers who are then targeting to be partners in our open innovation testbed, also after the project for 5 years to serve the industries and small and medium-sized companies to develop novel products for the future. So this was all that I thought that I give as an introduction, and then otherwise in this webinar we are concentrating on regulatory issues, and then in the end of the webinar we also show 3 of our interesting demonstrators what we have already done in the project, and which are ready to be disseminated in different events. So I think that if there's maybe not need any questions at this point, and I would like to ask the first presenter to be ready to talk about the regulatory analysis. And we have Marina Reina from INN-PLUS. INN-PLUS is one of our partners, and talking about regulatory analysis. Yes. Ilona, did you see this online? And if you have any questions, you can use the chat to put them there, and then we will take the questions a little bit later. Okay. Yeah. Okay. This doesn't fly. No, it's good. Yes.
Well, first, good morning for everyone, the people who will stay in the other side. Well, my name is Mariana. I need the microphone. Yeah, yes. Really?
You're not speaking as loudly as I do.
Okay, I try to do everything at the same time because I need to read more. Okay, well, I try to do it. Okay, well, I'm Mariana, I'm from INN-PLUS. My presentation is focused in 3 topics. Well, this is the name of the presentation: regulatory analysis, bottles, NEC, and regulatory barriers at European level for nanomaterials and biobasic products. Well, the first one of these topics is the regulation of chemical substance and mixtures. The second one is about other documents that regulate or are going to regulate biobasic materials. And finally, I show you some draft legislation which probably concern to all plastic industry or for all industry. One, what is INN-PLUS? INN-PLUS is a technology center with more than 30 years experience in the plastic sector. And our proposals add value for companies, add value for society. We have pilot plants and laboratories. And if you want more about 10 Plus, you can contact with us. So we don't have too much time for this reason. I'm so fast. I try to be fast. Well, REACH is the European regulation of chemical substance. This is the complete name of the document. It's too large. For this reason, everybody only say the REACH. And when I start to work at INN-PLUS, the first things that I want to understand is what is plastic. And generally people think that they know what is plastic and what is not plastic, but it's not so easy to understand. For this reason, what is plastic for the law? Well, as a lawyer, I look for the answer in the legislation, and I suppose the regulation of substance has the definition of this, but it surprised me because on REACH we have not the definition of plastic. Other regulations about plastic define it. So plastic is a polymer as defined in REACH, with one exception, is natural polymer that have not been chemical modified. Well, these exceptions are going to analyze soon. And the next question is, what is a polymer? And a polymer is a sequence of monomer. Well, and the rest of definition requires technical knowledge. Most of you understand it better than me. So in a simple way, we can say this is a monomer and this is a polymer. But now we try to understand what that means, natural polymer, not chemical modified. And natural polymer, first part. Polymer, which are the result of polymerization process that has taken place in nature, independently of the extraction process with which they have been extracted. This is important. The example of this are the lignin extracted from wood or corn starch obtained via wet milling. So the relevant things that we know to decide if some material is natural polymer or not is the place where the polymerization has taken place. For this reason, for the legislation, PLA is considered plastic because the process for the polymerization process of PLA is industrial process and not chemical modified. What is it? Now, well, not chemical modified substance means a substance whose chemical structure remains unchanged. So we should consider only the difference between the ongoing and the result polymers. Well, a summary of that is plastic is a polymer, could have been additives, but the important thing is what is plastic and what is not plastic, because the regulation about one material or the other is very different, could be very different. Well, in the same document, the nanoforms and microparticles are regulated. And what is a nanoform? This is the next question. A nanoform, the nanoform, we could say a particle with external dimension is in the size range 1 nanomillimeters to 100 nanomillimeters. Could you see the nanoform? No, it's impossible. It's a joke. It's impossible because we can see it with human eyes, but we can see very well the requirement of these nanoforms. And the most important requirement for the nanoforms is the substance. For substance where are dangerous. For this reason, the information and labeling is very, very important. The communication to the user about hazards to health and environmental. And there are the places in the document where these nanoforms are regulated, yes, in the different annex of REACH. And recently, the regulation has been amended, introducing a new restriction for synthetic polymer microparticles. And this restriction is shall not be placed in the market, these particles, if they are equal or greater than 0.01% by weight. But to understand better this restriction, like always, it's important to know the rules and exceptions. And what is the rules? The rules, they may be solid. Okay, they are solid and shall continue 1% of the weight of the particulars or on the coating. While the dimensions and length are determined 5 millimeters per particles for particles, and the other point is for fibers. And now the exceptions. Well, the first one is normal, naturally, because it's a natural polymer, and we know this is not plastic. And the other exception is synthetic polymer with could be degraded. Is in a similar way than compostable, but in this case include some different things. So it's important to see the Appendix 50. Other exceptions, polymers that have solubility greater than 1 gram per liter. In the Appendix 60, you can see the requirements. And the last one is polymers that do not contain carbon atoms in the chemical structure. Well, honestly, when I read it, I surprised me because I suppose every polymer have carbon, but not. The most commercial polymer without carbon is the silicone. Yes, and this is new for me. Well, these are excluded, polymer excluded for the materials, but there are another exclusions for the uses. For example, the uses in the industry. If we don't have this exception, we can use the pellets, for example, or exception related to way to prevent the dispersion of these microplastics or microparticles in the environment. For example, when they are incorporated into a solid matrix. So now we know what is plastic. Now we know something about nanomaterials and the restriction for microplastics. But for this project, it's important to know the regulation on bio-based plastic. What are the legally binding documents that regulate bio-based plastic? Well, we currently do not have a specific document for these materials. For this reason, I try to explain what the situation now. Well, the European Union has many institutions to have up in the government. One of these is the Commission. And what the European Commission do? Well, a lot of things, but one of them is to propose new European law and policies. The Circular Economy Action Plan is one of these policies. It's not a legal document, it's a political document. And I think it's important to know the scope of the document, the difference between trends, ordered to member state, and legal obligations. When we have a trend, we need to start to research. When we have an order to the member states, we need different solutions. But when we have a legal obligation, we need a solution right now. Well, what documents do we have about bio-based plastic, which will serve to prepare the regulation proposal in the future? This document, the Circular Economy Action Plan, European Policy Framework on Bio-based, Biodegradable and Compostable Plastic, and European Economic and Social Committee Opinion. All these documents are on internet. You can find it. And my recommendation is read it because it's really, really interesting. Oh, for me, it's interesting and really important. And what this document detects as challenge and opportunity for these materials, for bio-based materials? Well, challenge and opportunity. all this other information is taken from these documents. Challenge, well, to fight greenwashing and avoid misleading consumers. Well, the consumers need more information to take better decisions. This is true. And in my opinion, the key to transition to a circular economy is a consumer education about these issues. The second one, challenge, is ensuring biodiversity and the responsible use of farmland. We don't want farmland to stop producing food, to produce raw materials for plastic industry. We are very worried about it. And the last one is increase knowledge in the circular bio-based plastic through life cycle analysis. Well, INN-PRESSME project is perfect to address this challenge. And now the opportunities for these materials. Help meet the climate neutrality target, new uses for bio-based plastics for long-life products, this is the recommendation, and to inform correctly about the management of bio-based plastic waste in order to maximize its use. Well, we analyze what is plastic, we analyze bio-based regulation, and what's coming soon. Like a movie, you know, it's so exciting. Sometimes it's exciting, well, it's exciting for me. What is coming soon? Well, obviously, the regulation that generates the most expectation is about packaging and packaging waste. But I want to show you other legislation proposals that may affect the plastic industry. One of them is eco-design requirements for sustainable products. The other one, well, this legislation take the digital passport. So the next one is the preparation plastic pellet glues to reduce microplastic pollution. This is a very, actually, you know, that's very normal because in Galicia we have a big problem with pellets. And the next one is Green Claims Directive. Well, it has been approved the last week in the Parliament. And the last one, well, is really important because it's going to be a legally binding document. For the reason, the proposal for an international plastic treaty is really, really important. We must not lose sight of the progress of this proposal because they may bring new restrictions and with them a new challenge. Well, and in my opinion, for me, new challenges are not bad news. New challenges are always new opportunity to increase knowledge and continue progressing. Well, thank you so much. Sorry for speaking so fast, but well, if you have any questions.
Okay, thank you, Mariana.
Okay.
And please write your questions to chat, and then we move on to the second presentation. And I welcome Ulrich Lebeler from SEPI to give a presentation about recycling of fiber-based packages. Please, Ulrich.
Thank you.
Yeah, you can use this microphone.
Thank you, Ulla. Thanks for the introduction. Should I go there?
Yes.
I will just test again the little.
Okay, you can start.
All right. Thank you. Thank you, Ulla, for having invited me to this presentation about paper-based packaging. I would like to introduce a little bit about the about SEPI first, and then try to make the link both to this question about fiber-based packaging, where are we today, but then also what are the challenges with the legislation that is ongoing. I think everyone knows maybe about this packaging waste regulation. I think that was meant, but then also this question about open loop, closed loop recycling, product loop, material loop. And hope this can be useful for the audience and for the project. So CEPI is the Confederation of European Paper Industries. They represent towards the policymakers in Brussels about 500 pulp and paper companies with about 900 mills, 139 biorefineries, 180,000 people being employed, and 19 member countries everywhere where there is paper production in Europe. Missing a few, but representing more than 95% of the production in Europe. Yeah, so we have different areas. We have of course, we work a lot on energy and climate change. So the paper and pulp and paper industry is very, of course, energy intensive. Of course, we use forest raw material as a basis. But in the meantime, most products are based on recycling, and so these are big areas in our activities. And overall, basically, a core of the sector is to transform wood and then pulp into cellulose and bio-based products from a sustainable source, being wood from sustainable management in Europe mainly. So more than 80% is coming from European Union and then being certified, and then we keep the fibers in the paper loop to a very high extent. So overall, we reach a 70.5% recycling rate at the moment. But today, I think, and of course, that is a whole circle, also interconnections with the sawmilling industry, because wood goes, of course, to primarily then first to sawmills, the better bits that are then going into panels in constructions. So there are a lot of circles in the industry to keep wood fibers in loops, open loops, closed loops. But then today we talk then more about the recycling here in the paper and board sector, and then more specifically paper packaging recycling. We have a declaration about paper recycling in Europe. So as I said already, we are currently at 70.5% recycling rate for paper. So that includes all paper, packaging, printing paper, tissue paper, all kinds of special papers, wall papers, anything. So that is why often the question is, what is happening with the remaining 30%? So that a lot of that is, for example, also tissue paper with products that you cannot collect or you cannot recycle. And that is why this number, we have committed to increase that number. And the target so is at the end 76% by 2030. That is what we try to achieve. And since 20 years, there is this declaration to increase that rate. It is in the case of paper, we call it a closed material loop. So the recycling, when we talk about the paper recycling rate, it's a closed material loop. It's not a closed product loop. So it's not necessarily packaging to packaging and newspaper to newspaper, but mainly it's that. But overall, it is a closed material loop. So basically paper back to paper. And then we have down here the different grades of paper for recycling, so mixed, or then basically the brown grades, corrugated and graph papers. And we have the newspapers and magazines, which are so publication papers broadly, and then other grades. So these are then special grades, so-called high grades. And you see that mostly this corrugated and kraft is then recycled back into the production of case materials, so for packaging, for transport packaging, and so that is the biggest block. But they are also then used for other packaging papers like carton boards, you know, including liquid carton, for example, or pharmaceutical packaging, other packaging, wrappings, and so on. But also a little bit goes into tissue papers, so sanitary, that is a lot of toilet papers, tissues, tableware, and then others. And then we have this white loop, or this non-packaging loop, so for public graphic papers and newsprint. And so these are collected and go mainly back into this cycle. But some of it goes also into packaging, into tissue paper, or into other papers. And so we believe it is important to make clear that we have, I think it is a very, very valid question you asked me. So to develop on open loop, closed loop recycling, because of course, to increase this recycling rate even further, it is good to close loops, but not to exclude that material can also go into other loops. And what is important is to collect that material and find the most valuable uses for that. And that needs to remain a market dimension as well. Overall, I think with this increased recycling, what could be achieved over a long period, you see here, we're collecting this data since early 90s, is that the production of paper and board, so all kinds of paper and board, has increased by 31%. But the use of the virgin material has actually slightly decreased over the same period. So all the increase has been achieved by the recycling. Now moving to only packaging, because I think at the moment, and that is also part of your project here, and of course in legislation, of course the talks are about packaging. Music plays in packaging. So here we see that we have the different packaging materials that have to reach recycling rates, recycling targets. And we see here that most packaging is indeed paper and board packaging. But in paper and board, we reach already more than 80% recycling rate in paper and board packaging. So it's higher than paper in average, because we don't have these non-collectible papers. And only a small share is left that is not recycled. While in other loops, you have already less volume, but overall, basically, there is more paper that is paper packaging weight that is recycled than all the packaging, all the other packaging materials combined. And I think one success is indeed that we have very closed loop and open loop, closed product loop and material loops combined to make sure paper stays in a paper loop. I think packaging and packaging waste regulation revision is something people all have heard of, more or less. And so there are a lot of aspects to it. So for example, there are proposed bans. So some formats are suggested to be banned. Targets on reuse, I think, is a lot discussed, and gets a lot of media attention as well. So how to make more reusable options in packaging. Then also reduction, so how to get packaging waste really down. But this the regulation is also impacting, of course, and creating a discussion about recycling. So there are recycling targets for packaging, but then also the questions: what is recycling? How can we assess recyclability? And so there I want to spend just a few moments there. So for packaging recycling, there is a need for packaging to comply with design for recycling criteria by 2030. And those criteria will have to be still elaborated in delegated act. And that should happen by 27. And then there is also the need by 2035, because you asked about what are these targets, these challenges by 2030. Also the need to be recycled at scale, meaning being collected, sorted, and recycled by 2030. So these are the requirements. They are not final yet because the institutions are still discussing it right now. But by the end of March, we should know how exactly it will look like. And then on the targets, so the target for paper-based packaging is 85% by 2030. We are at 82 at the moment, so we believe in paper this is an achievable target, but we need still further separate collection of that material so that it has the chance of being recycled, actually, because what is not collected cannot be recycled. So then that is why we need separate collection targets. We have and then this compliance with DFR criteria need to be designed for recycling. They need to be efficiently and effectively collected, meaning they need to be, the consumer needs to recognize it's a paper product, put it into the right bin, and they need to be then collected into different streams without negatively impacting other streams. So that is the question about how many tons, commingled collection, separate collection, to keep the quality of the material, because that is important there. They have to be recycled in a way that the secondary raw material is of sufficient quality to substitute primary raw material, and then the recycling at scale. And also here in the debate, there is the Commission. In the Commission proposal, you see there is nothing about high quality recycling, because the Commission sees it in a way that this question about what is closed loop, what is open loop, what is high quality recycling, that is a question of the next revision of the Waste Framework Directive, or the Waste Directive in general. But here the co-legislators, Parliament and the member states through the Council, they have introduced definitions for high quality recycling. And so now there is this debate about what is high quality recycling in the context of packaging, but that might not be the same. We believe that needs to be looked at more broadly. You cannot just have this discussion in packaging. So that is why we believe it was right from the Commission to discuss it in the Waste Directive, so more broadly. In packaging, what is important that it not to see too close, just as a closed product loop, because meaning, I don't know, pharmaceutical box recycling back to pharmaceutical box, because then you lose the opportunities of using the material in other applications that are as good quality as being just in this little closed product loop. So a closed material loop where it goes back to paper. That is the important thing in our view. But the Commission has started work on this with this JRC report about definitions and in the context of recycling. We are preparing with a test method. So we have a test method to test the recyclability of paper products. Can be downloaded here. And we have also made our proposals on a vision how collection should be organized. More harmonized in Europe, meaning having really two streams with the monomaterial and the classic paper collection, and then have a second stream that can be commingled with other materials, and from which then more laminated products or products that are more challenging to recycle can be sorted out and then are recycled in special mills. That is how we see it. So this classic recycling stream, so recognize the product, have also marking harmonized, potentially even colors harmonized here, to have really this classic paper stream, paper and board stream together. And then with more products that cannot be recycled everywhere in all the paper mills, but need special treatment, they need to be also collected and not going for incineration and going into this second loop that is then recycled special. So that's how we see it for paper. And I think that brings me to the end of my presentation. I can't go further anymore. I don't know. So I stop it here because I think I used 15 minutes.
There's more.
Some more publications but you all get the presentation. Maybe one last, if you go back to that one, please. So we are organizing European Paper Recycling Awards, and so the next one will be 19th February, hosted by Susana Solis from Spain in the Parliament, and there's a link to register for it if you're interested. Thank you very much.
Thank you, Ulrich.
Thank you very much.
There are questions in the chat, but do we take all?
We take the questions in the end, so we are running a little bit late. So just making sure that everyone has enough time to present. I would like to now invite the third speaker, Arnold Littner from IPC. IPC is also our partner, and Natalie makes your presentation ready. So here you have a mic, and I can take this one. Okay. Thank you.
Good morning, everyone. I'm Arnold Littner from IPC, Research Deputy Director. My presentation is going to be about the challenges and opportunities of the recycling of bio-based plastic packaging in the PPWR. Very briefly first, IPC is the French Technical Center for Plastics and Composites. We are under the delegation of the French Ministry of Bioeconomy. Our mission actually is to improve the competitiveness of the French plastics industry. So we're in touch with about 2,000 companies. We are on a daily basis in contact with them. We know very well their needs. That's our mission given by the French state. Everything I'm going to say today is based on a document, which is actually the version of the PPWR, so packaging waste regulation, which was adopted by the European Parliament end of November 2023. You have the link to the document at the bottom of the slide. Let me say that it's not the final version of the PPWR. There will be additional modification, and most of the articles are still subject to interpretation. So what I'm going to say today is also a kind of interpretation, okay? So to be discussed. We had this morning already the definition of, thank you very much, of the plastic. Now I'm going a step further. I think it's important to say, to give the definition of a bio-based plastic. So I'm using here EU standard, the EN-17615. It says that bio-based means derived from biomass. Bio-based plastic is a plastic wholly or partly derived from biomass, and the same for the bio-based polymer. So basically what I'm going to talk about today is here in the green zone, talking about bio-based plastic, either biodegradable, let's say, for example, the PLA, PHA, PBS, starch blends, and so on, or non-biodegradable, for example, the bio-based PE, PP, or PET, also called the Europeans. So now, what about recycling in the PPWR? Article 6 of the PPWR gives some criteria that's for the recyclable packaging. It says that all packaging placed on the market should be recyclable by 2030. So we have here 5 criteria. One is about design for recycling, one is about the collection, one for the sorting, one for the high quality recycling, and the last one for the upscale of the recycling of the packaging. But there is no exact definition of recyclability. So what I did is that I went back to the same EU standard, the 16615, which said that recyclability is the potential of items or materials to be recycled as defined by relevant standards and regulations in force. So regulation here, I would say, refers to the PPWR, but what about the standards? Is there any standardized definition of recycling? And in the same standards, EU standards, we can find different definitions for recycling. So there is mechanical recycling, there is physical recycling, chemical recycling, but also organic recycling. And organic recycling refers to composting or anaerobic digestion, right, of organic waste under controlled conditions. The question is, would that count within the PPWR? So if we go in the text of the PPWR, there are some rules of the calculation for, let's say, for the attainment of the recycling targets. And it says, indeed, that biodegradable packaging waste can be considered as recycled materials when they enter either aerobic or anaerobic treatment plants. Okay, so in other words, organic recycling is part of the recycling targets for the PPWR. There are some conditions, it's true. We must justify that if it's composting, there is some results and benefit to agriculture, or that there is ecological improvements. But that's, I think, very important to know for biodegradable bio-based plastic. If you go for composting or anaerobic digestion, yes, that's recycling. So here is an example. If you put in the some biodegradable bio-based packaging inside the collection scheme for organic waste, you bring it to the organic recycling plants, and you go for either production of methane or compost. That's organic recycling. That's okay, again, for PPWR. Okay, so that's a good news, I think, for the biodegradable bio-based plastic. But I also would like to emphasize that we should also go for either mechanical or chemical recycling of those biodegradable plastic. It's not because they are biodegradable that we go only for organic recycling. We have here 2 examples of 2 companies which are working on the mechanical recycling and chemical recycling of PLA. So Total Corbion and Futero. Futero is going to to build a production plant and a recycling plant as well of PLA in France. So that's very good news. But we are not talking here about packaging, which are going to enter the composting or the anaerobic digestion streams. We are talking here about packaging, which are going to be within the mixed household packaging waste stream. So what does happen actually? And that's a good question, I believe, to go into. If we have some bio-based packaging waste inside the mixed households packaging stream, that will enter the collection stream we have almost everywhere in the EU, and they will reach the sorting center. And what does happen at the sorting center? So we have basically some bio-based PP, PET. We have already some in the market. And we will have also the PLA, PHA, PBS attachments, the biodegradable ones. So if we look at what happens for the bio-based PP, and PET, for example, well, they have the same properties of the fossil-based plastics. So they will be recognized as such, and they will be directed towards the right waste or sorting and recycling stream for PP, PE, and PET. So the life will be very easy. They will be recycled. That's very good. But for the other ones, what does happen? Actually, for PLA or for the biodegradable ones, there is no waste stream, no sorting, and no recycling stream. So they are not identified as such in the sorting centers. They are identified actually as contaminants. So if there are contaminants, they are led or they are directed to incineration sometimes or landfilling. And that's a pity, because those materials have an economic value, first of all, a high one. They are much more expensive than the other ones. So there's a great loss of value, definitely. It's also a pity because we know that it is quite easy actually to identify those materials in the sorting centers as biodegradable plastics. There we have here two examples of EU projects, Sea Life and ENN-PRESSME, which demonstrated clearly that sorting those kind of plastics in sorting centers is, let's say, is quite easy, but we need additional sorting machines. And if we need some additional sorting machines, we need to make that profitable. And today it's not profitable because the market for those biodegradable plastic is still too small. So we don't have the massification we need to make those investments profitable. And this is why they are not sorted today. So just as a summary here, for the bio-based packaging, which are into the mixed packaging waste stream, it's working very well for the bio-PE, PP, and PET, for example. It's not working for the biodegradable ones because there is a lack of compatibility of those plastics with existing sorting recycling infrastructures, especially sorting infrastructures. So potentially they could be either organically or mechanically or chemically recycled, but it's not the case, okay, because of lack of investment. Just going a little bit back to the composting story in the PPWR. The PPWR mentions that there are some packaging that should be compostable in industrially controlled conditions. They mentioned the sticky labels attached to fruits and vegetables, the very lightweight carrier bags, and tea or coffee bags. Those ones should really be compostable. Of course, there is some risk. We need to make sure that locally there are collection systems in place, also that there are some bio-waste treatment facilities available to treat those kind of materials, of products. It doesn't mean that only those packaging can be compostable. Okay, other packaging can be compostable. There are still some conditions that must be designed to enter the organic waste stream at the end of their life. It must be proven that it will increase the collection of organic waste, and of course, they shouldn't contaminate the fossil packaging waste stream. So if an industry wants to develop, to put on the market or biodegradable, bio-based packaging, it's okay. Still, that they have to follow those rules, and probably it would be good for them to have some kind of guidelines for the design of this kind of packaging. The last thing is the opportunity for bio-based plastics to play a role in the recycled content targets of the PPWR. Article 7 gives some targets by 2030 for the integration of recycled materials into packaging. So there are some targets, for example, for contact-sensitive packaging, except PET or composed of PET, another objective for single-use plastic beverage bottles, and so on. And actually, the PPWR says that by 2025, so next year, the European Commission is going to produce a report to assess the opportunity for bio-based plastic to contribute to achieving the target for recycled contents, up to 50% of the target. So basically, for example, if the target is to incorporate up to 30% of recycled content by 2030, and the industry cannot do it because there's a lack of material, there is a lack of purity or problem with the purity of the material, then it could be possible to add into the product up to 15% of bio-based plastics in the product. From our point of view, this is quite nice for the bio-based PP, PE, or PET, not for the biodegradable ones. It's going to be more difficult from a technical point of view. But still, it's a nice opportunity to boost the bio-based markets. So as a conclusion, the main one is that we need some economic incentives to boost the bio-based packaging markets, because it's still too small to justify investments, especially in the sorting centers. Okay, we need to make the investments profitable. Important from technical point of view, organic recycling works, mechanical recycling works, also chemical recycling. That's a strength for bio-based packaging. They need to be designed for sure to be recycled in such a way or the other way, but it's really a strength. And like I said, we need to look at the opportunity to contribute to the target for recycled content by 2030. So the European Commission is probably expecting some inputs from the RTOs. So we need to do that very probably. And thank you very much.
Okay, thank you, Arnold. Very nice presentation about the situation. And if you have any questions to him, so please write them in the chat. And then we move on to other industrial area. And the next presentation will be through the Zoom. So we welcome Tribord Mori to present the situation and regulation about recycling plastic parts in the automotive industry. Can you unmute your microphone?
Can you hear me?
Yes, we can hear you.
Okay, perfect. I will try to. I'm not sure. I have my camera.
The camera is
Start video.
Now
Okay,
it's
perfect.
on. Yes.
Good
Okay.
morning, everyone. Good. And I will share the presentation, so it should work. Can you see my screen?
Yes.
Okay. So it's
okay.
Perfect, thank you. Yes, good morning, everyone. I'm Thibaut Maury from the Joint Research Center of the European Commission, and today I wanted to present, I had the opportunity to present the work we have done with colleagues over the last years. It was a 2-year study in the context of the revision of the end-of-life vehicle directive. And the main purpose of this GRC study was to let's say, analyze the feasibility of recycled plastic content target in new passenger cars. So first, I will be very quick, but just to present a bit my organization. What is the Joint Research Center? Because we are a bit a strange animal in the Commission galaxy. Let's say that we are the science and knowledge service of the European Commission, and we provide independent fact and figure to support EU policies. So basically, we are supporting the colleagues in policy directorates, and to hopefully positively impact the society. And most of our staff is in fact scientific staff with so PhD degree, and basically we are a research organization or a research center. We have several GRC centers across Europe. I'm personally based in Ispra, Italy, but we have also colleagues in Seville, Spain, in Brussels, and also in Germany and Netherlands. So with this, just I will try to be not too talkative, because it's a very interesting topic and I could speak for hours, but to be brief, just to present you quickly a bit of policy context, then the state of play for use of plastics in vehicle, and the proposed policy option we have done to our colleagues in the DG AMP. And then I will finish the presentation with some perspective and some potential future work, because you will see it's a work on progress, and so it's only the beginning of the story of recycled content target in vehicles. Yeah, and just maybe one precision: all the results and so on, you can find it in the public report, which is just here. You have the cover page. Entitled "Toward Recycled Plastic Content Target in New Passenger Car and Light Commercial Vehicles." So our goal was to, at the GRC, to propose, let's say, circular measure for the revision of the end-of-life directive, and it's now a regulation, meaning that in July, so last summer, it's a proposal for regulation. Last summer, it has been published or released under the name of Circular Requirements for Vehicle Design and on Management of End-of-Life Vehicles. And it's quite important to see that the ambition of this regulation is really to link the design on one side, so the product policy, and on the other hand, the waste policy with the management of end-of-life vehicles. And so at the moment, the proposal is here and available, and the co-decision process should start soon. What are the problems, in fact, for end-of-life vehicles, and more particularly for plastics in end-of-life vehicles? So basically, we have a lack of circularity in the automotive value chain, and a poor quality of the waste treatment, and it's particularly true for plastics. A bit less for aluminium and steel, but for plastics is true. We are also in a context where we have a high dependency in imported raw materials, and when you speak about plastics, basically there is an oil market behind, so it's also important to see that more circularity could also reduce our import dependency in terms of oil. And then there is also a lack of circularity for the automotive value chain at the end of life, because basically 1/3 of vehicle is missing, meaning it's what we call the unknown whereabouts. So for the collection rate, it is actually quite low, with 1/3 of the flow or illegally exported or not accounted for in official statistics. So there is here a leakage in terms of materials, and particularly of plastics. Our approach regarding the study on recycled content target for vehicles was really to consolidate data and knowledge about the use of recycled plastics and also the end-of-life vehicle treatment to understand better let's say the plastics flow in this value chain. For this, we consulted car manufacturer, plastics manufacturer, but also, of course, recycler, and we visited several recycling facilities across Europe to understand how the plastics from end-of-life vehicle is currently treated and what could be the future possibilities. And yeah, our study is really a technical study based on fact and figure and scientific model, and I think it's quite important to highlight. So basically, regarding the state of play, if you look at the composition of a car today, you have around 200 kilograms of plastics in a car, which represents, for an average car, which represents 16% of the material mass. In fact, you have in the car you have in the street today, you have already certain amount of recycled plastics, which is around 7 to 20% in plastics mass. Of course, it depends a lot of the car manufacturer and the models. But the main issue is this recycled plastics is not coming from post-consumer recyclates, which is like really negligible. It represents only 2.5% of the plastics in the car. But most of these recycled plastics come from what we call pre-consumer, meaning that coming from production, scrap and waste. And there is, as I already mentioned, important disparity. You have some model which already use a lot of post-consumer, some not at all, and some, let's say, car manufacturers are already front runner in the field that already are committing to integrate recycled plastics in car, and it's part of their, let's say, responsibility and sustainability approach. But some are really lagging behind with only very few percentage of plastics included in the. And now on the waste part, in theory, the recyclability of vehicle is very high. By law, it's 85%. But the fact is, in practice, and mainly for plastics, there is a really poor recycling of plastics in vehicles reaching end of life. Basically, the waste stream is quite important because we have like more than 6 to 7 million tons of ELV collected in 2019, and this represents around 1 million tons of plastic waste. The problem is if you have to keep in mind only one figures related to plastics in ELV in end-of-life vehicles, is that only 19% of the plastics goes to recycling, which is really, really few. And that means that most of the plastics is not at all valorized, or it's burnt or directly landfilled. And this comes from, on one side, the limited design for recycling practices today, and the lack of economic incentive, because the recycling of plastics is mainly dependent of the volatility of oil market. When the oil price is low, the recycler gets no interest in recycling plastics. There is potential valorization for aluminium and steel that have a great value on the market, but for plastics is much more difficult from an economic point of view. But it should be mentioned that the technology, and mostly post-shredder technology, are available in the market, and it's already possible to have good recycling rate for plastics from end-of-life vehicle waste stream. And so it's the maturity of this technology is easier. Based on this state of play, basically we can justify the fact that increasing the recycled plastic demand through recycled content target would help, in fact, to attract investment to go toward more post-shredding technology and more valorization of plastics waste stream in end-of-life vehicles that will allow to have a higher quantity and better quality of recyclate in the automotive value chain. So for the proposed policy options, In fact, if we think that the target, the recycled content target might be a good instrument, then we have to take into consideration the fact that it's a whole value chain effort. And I don't want to enter too much in the detail here. You will find all the methodology in the report we published. But just to show you that we took into account several criteria along the value chain. One of the most evident one is the criteria 1, so which is about should we consider pre-consumer recyclate or post-consumer recyclate? The answer is clearly to go only for post-consumer recyclate. I don't want to enter too much in the detail on all the criteria, but just a second criteria we took into account is closed and open loop. So should we take into account only plastic recyclate coming from end-of-life vehicle stream? We thought it's not feasible, of course, because you never will reach 100% efficiency. So 100% closed loop is not feasible. To the contrary, 100% open loop can be, let's say, dangerous or could jeopardize the whole recycled market, because basically the car maker has a huge economic power, and there is a risk of cannibalism to buy the recycled plastic stream. And for example, it could put in danger the achievement of other targets, for example, in packaging. So it was important for us to, for this recycled content target, to take into account a mix of closed loop and open loop, and not going through 100% open loop or 100% closed loop. Then the other criteria, I won't detail here too much. And once we have, let's say, define which criteria should be integrated in the target, also the main objective was to define what is the appropriate level of the target, which ambition. And for this, we based our assessment on material flow analysis in the sector to see today how many plastics is recovered from end-of-life vehicles, and tomorrow what will be the situation. And then based on this understanding, we derive several policy options. So you have here one example of the policy option on the left of the slide. So we had several options with, of course, the ambition which were not the same. So basically an option 4A, which was about 15% of recycled plastic content in 2030. The option 4B, which was 25%, and the option 4D, which was about 30%. And of course, higher is the ambition, higher is also the risk to have imbalance on the market between the supply and the demand, because we need to be sure that if you put a target, the industry will be able to follow and to provide recycled plastics in good quality. And so basically we did this kind of exercise to quantify what will be the supply-demand balance. And so here also, I don't want to enter too much into detail, but just to show you that we've done the calculation, and you have here an example of the graph where the blue bar will be the demand in terms of recycled plastics if the targets are adopted. So with regard to the options, so we have 4A, 4B, and 4C for the ambition. And then we will have what the automotive industry is able to provide in terms of recyclate, which are the dots. And we see, based on our quantification, that no imbalance is expected in the coming years, and that an option like an option 4B is feasible regarding the material flow and the balance between supply and demand. And so just to also show you what is the main outcome of this study regarding minimum recycled content for plastics in vehicles. Basically, if you look at the Commission proposal now, which is out, and you go to the Article 6, which is minimum recycled content in vehicles. So the Commission proposed to have mandatory recycled content target for plastics in vehicles, where Basically, it is mentioned all the criteria the GRC analyzed. And so it is proposed to have a recycled content target of a minimum 25% in new vehicles being type approved for 2030 or 2031. It depends on the time of the co-decision process and so on. But in the coming years, basically, if this proposal is adopted by Parliament and Council, we will have a minimum share of recycled plastics in vehicles. And it's worth to mention that it's not only a target, so 25% of recycled content, but there is also a closed loop criteria that you can see in red, which is a minimum closed loop criteria of 25%, meaning that 1/4 of the recycled plastics entering in the composition of the car should come from end-of-life vehicle waste stream. And it's quite important to be sure that there is no risk of cannibalism of the plastics waste stream by the automotive industry. Then what's next? So at the moment, it's a Commission proposal, so there is still decision to be taken by the Parliament and the Council. But another thing which is really important is the implementation and the feasibility of these targets. Basically, in the first phase of the work, we have defined the level of ambition, or what the target should look like, and the main criteria, properties, and so on. But now there will be a massive effort on putting the calculation and verification rules. So it can be based on already existing standards. I put here a picture of basically what has been done for recycled material content in energy-related products. But basically, we should have the same for recycled plastics in vehicles. We also need to verify the claim in terms of recycled content, and this is related to the certification scheme, which is really important to have a good traceability of recycled waste stream in Europe and also outside Europe. And so for this, we will have to work on the certification scheme and on also the verification. And here we put an idea about what is called in the automotive industry IMDS, which it's a material data system, which is shared between supplier and automotive car makers. And this could be a good tool, for example, to also track the content in terms of recycled plastics. Of course, recycled content target is not a magical tool. So basically, it needs to be also accompanied or going with other kind of provision. And it's also the ambition of the end-of-life vehicle regulation, where you have recycled content, but not only, because it would be too easy to put the burden only on a car maker saying, look, you need to have recycled plastics in your car. But there is also mandatory provision regarding design for recycling, but also recycling efficiency targets, which is particularly the Article 34 of the proposal, which is important, with a minimum recycling efficiency for plastics of 30%, basically. So it's only it's a work ongoing, and with this, I hope I gave you a good overview of what is already proposed by the Commission and what will be the next step for the years to come. Once again, I refer to the report if you have a question and if you want to know a bit more. So thank you for your attention. I hope I was clear, and if you have some question, I think it's at the end of the session.
Yes, thank you very much for intensive clarification about the situation. We are running a little bit late now, so we have to move on. And we move on our test cases, what we have done in the INN-PRESSME project. And I kindly ask the presenters to be briefer. So 10 minutes for each of you. So skip some of the details, please. Yes. Yes. Yeah, we will have the questions then after the presentation. You take the Marta's presentation. So the next speaker is Marta Redraro from ITIP, and she's presenting the the bio-based plastic parts by 3D printing. And this is a technology that we have used in two applications for the car industry and then also for the consumer goods. So please, Marta.
Thank you, Ulla. Good morning, everyone. As Ulla said, my name is Marta. I work at ITIP, and we are in INN-PRESSME, the test case leaders of 2 test cases which are related to 3D printing. I'll use this better. Thank you. This is just a very brief overview of what we are going to see today. The objective of these test cases are to use bioplastics reinforced with fiber in the sectors of the automotive and the medical, the shoes, personalized shoes sectors. And what we are trying to do with this 3D printing technology is to print these parts for these sectors and achieve or reach the properties the same as the fossil-based pieces fabricated with fossil materials. This is the overview of 4 test cases. We start in the conversion that partner IWN. What they do is to provide different natural fibers, flax and hemp, and treat them to improve the compatibility with the biomaterials. Then at CEA and ITIP, what we did is the compounding of those biomaterials with the fibers provided by IWN. Then this is passed to IPC, that they produce the filaments, and then they are used in the 3D printing. In parallel, Fraunhofer developed coatings that they are used for antibacterial, to confer antibacterial properties to the materials. And finally, this is all passed to the end users, which are on one case CRF, Fiat, and Podactiva, to validate these demonstrators, these pieces that they've been fabricated. What IWN does is with these flax and hemp fibers, they follow a process. You can see it here: degumming, siliconization, drying, grinding, and ringing. The aim of these different steps is to clean the fibers, to improve the adhesion between the fibers and the polymers, to make them smaller, and to improve the purification. They are capable of producing approximately 20 kilograms of these fibers a day. Then these fibers, as I mentioned, they are passed to CEA and to ITIP. In the case of the automotive sector, CEA uses biomaterial, the polyamide 1010, and at ITIP for the personalized inner shoe soles, we use BioTip U. You can see here in the screen the final formulations, but to arrive to those formulations, it was necessary to do a lot of experiments, trying the different fibers with the different silent treatments, the different percentages of fiber. And after a lot of characterization and analysis, these are the formulations that we use for each sector. As I mentioned before, once we have the compound, it is passed to IPC, who specialize in the filament production. It has to be noted that having fibers into the biopolymers made it a bit more difficult to get an homogeneous filament, and a lot of different properties and parameters had to be changed to achieve the diameter and the homogeneity that it was required for 3D printing. If we go into the detail of the automotive parts, what CRF Fiat decided to 3D print is the Fiat 500 dashboard fascia, which at the moment it's a piece that is being fabricated using injection molding. But because nowadays they find that from the design center, there's more and more requests for a small series of personalized parts, they thought that this would be a good piece for the 3D printing, which will allow a shorter series, since the tooling that is required for injection molding is not required. Here you can see the pictures of the 3D printing of the fascia, which the people who are in the room can see the demonstrator just sitting there on the table. And as you can see here, we use the tree supports, which after trying different methods, it was the best to use with this polyamide. What we did in terms of validation, while we were getting the best parameters for the 3D printing, We did with 3D printed squares of 10 by 10 centimeters, which were printed just for validation purposes. And what we did is we coated 5 of them with the Ormoser developed by Fraunhofer, which, as I mentioned before, it provides antibacterial properties. These 10 plates, 5 coated and 5 non-coated, were sent to CRF for validation. Here you can see listed the tests they perform, and as an overview, the mechanical properties were up to standard, and they passed most of the tests except for the xenon exposure test. But what we saw is that the coating improved the capability to resist to these tests. Regarding the personalized inner shoe soles, it has to be said that this consists for each patient, the sole is, well, they scan your foot, Productiva scans your foot, and then the podiatrists decide what you require, because, you know, some people might need foot higher than the other, or more support on one foot than the other. So what Productiva does is they design this, apart from the sole that you can see in the picture, different designs, also what each patient needs. So what they passed us are different designs. As you can see, the first one printed is the one on the left of the screen, but it looked really nice and very light. But when the tests were done, it was seen that it didn't provide adequate support, especially on the heel area. So it was required to modify this design. That what we did is to fill that part that looks a bit more hollow. So you can see it on the right. But still, after some testing and some 3D printing, what we was decided is to fill the whole sole to give more stability, and to also to make the 3D printing a bit easier. So what you can see at the bottom is the final design. So what they did is to apply this design to 4 different patients. So we printed 4 different prototypes. And what we did, again, with the coating from Fraunhofer, is to coat one of the pairs, not to try the antibacterial properties, which were already tested at lab scale, giving really good results, but to see if the coating will have any effect on the material when submitting to the validation tests. Once we at IT printed the soles, it was passed to Productiva, because of course you need the upper part to be able to validate the shoes. And what they decided is to use 100% recycled materials to give the whole design a complete eco-friendly demonstrator. The tests, what they did is in these 4 different patients, what they compare is the generic shoe that you get in the shops. This generic shoe with the personalized Productiva insole, and also the custom footwear that we developed at the project. What they measure is mean pressures, maximum peaks of pressures, and the total contact surface area. And the 3 of them are like with the generic shoes off the shelf are the ones with worse results. Then with the personalized Productiva insole gives a little bit better results. And the custom footwear with INN-PRESSME, it gives really like a little bit better results than the second case. But of course, we will need a bit more test case, some more patients to actually validate it. And another test they did, which doesn't show the picture here, is the lifetime test. What they do, they replicate the walking movement up to 10,000 cycles to see if the sole suffers any breakage or deformity, and the results were good. There was no change in the shoe. So concluding really quickly, the automotive parts, we think that both test cases have really positive results. CRF has confirmed and has the confidence that this type of material and this type of technology can be used for the printing of interior automotive components. And Productiva has confirmed that the material of the project meets the specifications and the technical requirements of specialized podiatrists. So even if they are just prototypes, they have really good results. So we are quite happy with it. Thank you.
Okay, thank you, Marta. And really, we have the demonstrators there on the table. I'm sorry, in a Zoom, you can't see them more than in a presentation, but during the lunch break, you can have a closer look at the demonstrators here in Brussels. And as the next, we have a test case, which is targeting for packaging. And this is a fiber-based packaging solution that is designed to be recyclable in a fiber-based packaging loops. And this is presented by Ilona Leppänen, who comes from VTT. Please, Ilona.
Thank you, Ulla. Yes, thank you for the introduction. So I'm Ilona from VTT, and today I will be presenting you this multi-layer barrier packaging based on bio-based and fiber-based materials. It's nice changing the slides.
Try again.
Okay, no, good. So a little bit of background. So we all know that the global production of plastics is constantly increasing, and in 2021 it was 390 million tons per year, and currently it has exceeded over 400 million tons. And what we see also is that only a small part of all this plastic that is produced globally can be considered circular or based on bio-based plastic materials. And about approximately 40% of all this plastic that is produced is used for packaging applications. So it is a big sector. And of this, then half approximately is considered this multi-layer barrier packaging. And this multi-layer barrier packaging is consisting of various different layers that complement each other in the final product. So each of the layers has a specific target, so they can function as a barrier layer, for example, the oxygen or odors to keep the food fresh, or then serve as a structural layer to give support for the final material. And currently, these many of the layers are made of fossil-based plastics, and these are very difficult to recycle. So in INN-PRESSME, as Ulla mentioned, we are trying to upscale the production of these bio and fiber-based materials. And we have applications in 3 different sectors. And today I will be presenting you the packaging sector and these fiber-based, bio-based pouches. So the aim of this test case was to develop and scale up this multi-layer barrier packaging, which could replace then these fossil-based materials in the multi-layer packaging. And we demonstrated this in INN-PRESSME project using 4 different pilot lines that were available in this INN-PRESSME consortium. And the materials that were used for this multi-layer structure were this polylactic acid dispersion as one layer, then cellulose nanocrystals was one layer, and then we had also these bio-based hybrid nanomaterial dispersions as one layer, and all serving for a different function in the multi-layer structure. And then also the aim was, of course, to make this material in a way that it can be recycled in the current fiber-based streams. So then a little bit of background of the material. So the PLUX was produced at VTT's formulation pilot line, and PLUX is this water-based dispersion, which is based on polylactic acid and polyvinyl alcohol is used as the stabilizing and dispersing agent. And PLUX was used in this multi-layer packaging to enhance the moisture barrier of the packaging and also to provide heat sealability to the multi-layer. And we demonstrated in this project that we could scale up actually this production of this PLUX dispersion from only 2 liters in lab scale to up to 600 liter reactors. And the final material that we got out was 250 kilograms of this dispersion only in one batch. And it was done in this one pot reaction, so we can do the polymerization and also the dispersing step in the same reactor. So then the CNCs were produced at Rice, Sweden, using their CNC conversion pilot line. And these are produced by acid hydrolysis, and the raw material for it is pulp, but also Rice has demonstrated that it is possible to use also other raw materials, for example, side streams or waste streams to produce actually these CNCs. And they showed that they can have a concentration of up to 6 weight%, and the batch size was about 200 kilograms. And in this multi-layer, the CNCs were used to enhance the oxygen barrier of the multi-layer, so to prevent the food from spoiling. And then the third component in this multi-layer was Bioormoser from Fraunhofer. So they scaled up the production of this Bioormoser up to 40 liters. And Bioormoser is this bio-based lacquer, which is made of these inorganic nanoclusters, and it is actually a very multifunctional and flexible coating. So the basic components are the same, but then just by a little bit tuning the or adding different components, you can actually get different types of kind of functions of the material. So they can function as an oxygen barrier, which was the case here, and then also, for example, to give antimicrobial properties or antistatic properties to the final material. And here we use this 3-component system, which was stabilized by this biopolymer, so hydroxypropyl cellulose. So these materials, 3 materials, were then coated on 2 different base papers, were different grades with slightly different properties, but they're labeled as base paper A and base paper B in the results when I go to them. So the coating process then to apply these layers was done at VTT Sutka pilot line. So it is this very modular pilot line where we can apply these aqueous coatings. So basically the modularity means that you can modify where each of these compartments is located to kind of serve the customers. So you can kind of tune the structure of the pilot line. And in addition, there is various coating methods possible on Sutka, and we used in this project this reverse gravure coating method. So the trial points are here. So we have 3 different trial points that we tested. So the multi-layers consisted either of PLUX and Bioormoser PLUX or different base papers, or then we had this CNC layer in between to see if we can even enhance the oxygen barrier of the material by incorporating these CNCs in the structure. And we got good coating quality of all of these materials, and in pilot scale, we coated all of the layers with the Sutka at VTT, and there were no issues with the adhesion between the layers. So we got very, very good coating quality, and they are quite thin layers. So the whole multi-layer thickness is only about 7 to 8 micrometers. So we need very little material. So then to the water vapor barrier. So we see from these images, there's 3 different images in different relative humidities. Tested the water vapor, and we see that in green the base coatings on base paper A, and on blue the coatings on base paper B. And we see that when we apply the coatings, So compared to the reference, only the paper, we see that when we apply the coatings, we get a decrease in the water vapor barrier in all of the relative humidities, and it is more kind of the clearest decrease is to 50 to 65% in the 50% relative humidity. And what also actually with the base paper A, we get slightly better values because there's this pre-coating to also enhance the water vapor barrier. So then to the oxygen barrier, so we tested two different conditions, so in 0% relative humidity, and then also 50% relative humidity. And there's no references presented here because both of the base papers, they do not have any barrier for the oxygen. And we see actually that the base paper B, the coating on base paper B has a clearly lower oxygen barrier, and this is because the base paper B has a higher smoothness, so we get a better coating of the bioeconomy on the and blocks on the substrate. And also what we see here that we thought that if we can increase the oxygen barrier with incorporating the CNCs, but it's approximately the same with or without the CNCs. So when we moved further to the industrial demonstrators, we did the industrial demonstrated without the CNCs. And for all of these materials or the multi-layers, also the gas, grease and mineral oil barrier were very good. So then we moved with these two trial points, so the 3-layer structure Plux, bioeconomy Plux, coated on both of these base papers. We did this in Valky's industrial pilot line. So the Plux was coated at Valky, Ylöjärvi, and we got up to 500 meters of the coating applied. So we could go in very, very large scales. And then after that, the paper was sent to back to VTT, and then we coated there the bioeconomy Plux, and the final material that we got was 2,000 meters of the final multi-layer material. And these also had very similar barrier properties and an even enhanced oxygen barrier for compared to the pilot or the lab scale experiments. So the recyclability we tested as well, and we saw that actually when we have the CNCs there, it enhances the recyclability because it's kind of serving as this dispersing agent, so it helps with the delamination. And unfortunately, the samples without the CNC did not pass the test, but the tests are still ongoing for these large-scale industrial demonstrators. And then the heat sealability was achieved with the Plux, and we got a good heat sealability. With the large-scale demonstrator, heat sealability was slightly reduced because there were slight problems with the corona pre-treatment, but we can change this and also apply a thicker Plux layer to also have a good heat sealability in the industrial scale. And just to sum up, so we made these multi-layer coatings using bio-based materials on two paper substrates, and using these Plux, CNC, and bioeconomy that were produced at the INN-PRESSME pilot lines. And we could use these kind of standard coating methods, and also we demonstrated that it's possible to coat these in industrial scale, and we reached very good barrier properties both for water vapor and oxygen. Thank you.
Okay, thank you, Ilona.
And here's a demonstrator from the.
So one-sided demonstrator, so it's not printed the large scale material. Now we move on to the last presentation, and Christoph Mack from Fraunhofer will have the last presentation about test case related to packaging as well. And it's about reusable bio-based plastics. And now we get the slides ready. And part of the INN-PRESSME team is disappearing, but we try to summarize then later on the questions and by emails with them. Okay, please.
Thank you, Ulla, for the introduction. I'm presenting test case 3, the bio-based boxes. I will skip a little bit because we're short of time. With regards to the motivation, I think everybody knows why we're doing that. Climate change, oil often sourced from non-reliable countries, and recycling rates are too low. We have some, let's say, superior aims with this project. For example, reducing the CO2 footprint, for example, the increased use of renewable sources, but we also have a very technical aim during this project, and this is what I'm going to speak about, and this in the end should then contribute to reach these superior aims that we're aiming at. And the technical aim is to find a bio-based substitute for expandable polystyrene bead foams, and which has more or less similar properties compared to EPS, and which can be used in packaging applications. Our approach was to use a very common polymer. It's polylactic acid, very well known, bio-based, is recyclable, has a low price compared to all the other biopolymers, has a high availability, and as polystyrene has a high stiffness. We are looking into lightweight PLA foams. We are looking into natural fibers for the reinforcement of components, and we are looking into the 3D printing of individualized packaging elements and the process development for combining 3D printed parts with bead foams. When we look at the partner structure, we had on the left side the material suppliers with VTT and INN-PRESSME, two institutes who are dealing with the development of different natural fibers. Then we had partner CEA, who was responsible for the recipe development, for the 3D printing filaments, and also for the foam-based materials. Then we had Fraunhofer ICT for the development of the bead foam, and we had IPC and ITIP for the development of the 3D printing filament and the 3D printing itself. And in the end, we had our industrial partner, WSUBK, who is a producer of particle foam components for different applications. VTT provided some fibers, nanofibrils from cellulose. INN-PRESSME provided fibers made from flax and hemp, and in this case, it was microfibers. Both these were then incorporated into PLA to act as a reinforcement agent. The fibers were characterized in these compounds with regards to the fiber nature, the fiber treatment, the fiber concentration, and their influence on its properties. In the end, we can state that all tested fibers act as a reinforcement agent, especially with regards to the material rigidity. In the end, one material composition was chosen for the demonstrator. It was PLA with 10% of CNF, and this was then produced as a compound to be then reworked to filaments at IPC, where different testing was made with different compounding machines and extrusion machines to evaluate the influence of these processes on the material properties. And it can be seen that the mechanical properties, especially the tensor modulus, was improved with the addition of the CNF fibers. So now this is not working anymore. So with regards to the next steps, the first part of the demonstrator, we had partner ITIP, who produced a special part which was not suitable to make it with injection molding. It was a powder for a NFC temperature sensor, and ITIP did different tests with the filament produced by IPC and stated that the fiber reinforced PLA was easy to handle and to print. And so they printed various versions of this holder of the NFC logger. Here you can see a few images from the design of the holder over the printing process and then to the final components that were made for the demonstrator production. Then coming to foaming, we at Fraunhofer ICT did various tests with the fiber reinforced materials. But what we saw is that the incorporation of such fibers more or less hindered the foaming, or at least decreased the foamability of the materials. You can see this on the right image, where the more fiber we had inside the foam, the less good is the foam quality. So in the end, we decided to not go on with the fiber reinforcement, and we went with an alternative approach to improve the properties of the PLA bead foams. And this was also, I would say, the right approach in the end, as we, after quite a lot of tests and characterization, we could improve the properties of the PLA bead foam with regards to the fusion of the beads, mechanical properties, and temperature stability. This is just a quick chart showing that the compression strengths could be improved at the same density of foam just by modification of crystallinity of the foam by 60%, which is quite a nice result. Then at partner WSVK, the whole demonstrator process was implemented, meaning that they choose a special tool, which was in this case a lid of a thermal box. And they also designed this holder, which was printed by ITIP. And both was then, together with the EPLA bead foams from Fraunhofer, was sent to WSVK for the demonstrator production. And WSVK made a short video to give you an impression about how this demonstrator production took place at their production plant. After more or less as a preliminary conclusion, it can be said that the modification of the foaming tool at WSVK enabled the production of the demonstrator, and also installation of new sensors in their tool enabled the control of the process with regards to that very sensitive, temperature sensitive material PLA, which was used in this case. And as a final conclusion, we can say that we successfully optimized the material with regards to mechanical and thermal properties, so that we could produce such a demonstrator. We were able to incorporate 3D printed parts into the foam, and doing this in one molding step. The demonstrator was designed and produced, and the overall demonstrator is potentially recyclable. This needs to be proven, which will be done in the project. Coming to our demonstrator part, so you also have an impression how it looks like. We now have a non-petrol-based packaging demonstrator made from close to 100% renewable resources. Thank you.
Hey, thank you, Christopher. So there's possibilities to make also bio-based reusable packaging for packaging sector, and now we could move on to the questions, and we have quite many questions. So What shall we pick up?
We can start with the first one from Mathieu.
How do we see the paper complexes? Do they have to be 85% paper-based to be considered recyclable in a paper value chain? This is more to the Ulrich, maybe.
Okay, yeah, thank you. And thanks for the question. So this links to the question of recyclability and recyclability in paper. And yeah, the previous speaker from VTT sitting in front of me, I don't remember the name, sorry.
Ilona?
So you mentioned also that you tested with the SEPI test method for recyclability. And so here it is important that of course you need a certain yield, and so there it's a percentage, but then there are also qualitative parameters for testing. So you can have a packaging that has a lighter non-paper component, which with good performance on the quality of the end product, and you could have one that is stronger and is not harming recyclability that much. So it's not just about the percentage, but also about how it influences the quality of the end product. Generally, I think there is where we see a difference between somehow monomaterial and composite is 10%. But then on recyclability, you also have to look at qualitative parameters.
Yeah, we didn't present the recyclability testing because it's ongoing in details, but in some cases we had too much reject, but in some cases there wasn't reject so much. So it is something that can be used again to make the next generation of packaging as used in a raw material. Okay, then thank you. If we move on to there's another question for you as well. What is approximately the share of the plastic coated and contained fiber-based products in the open loop recycling stream?
So here, I mean, it's in the overall, let's say, so we have about 50 million tons paper based packaging and 80 million tons paper. Plastic coated, that's speaking generally, is about between 2 and 3 million tons. So I would say between 3 and 5% of paper that have then plastic laminations or of some sort. So thinking of beverage cartons, for example, coffee cups or other products that have been looked at. So I would say in the range of between 3 and 5% of paper products overall.
Okay, thank you. Then we have a question to IPC and ERS about the question about this bacteriostatic additives. Are they somehow influencing the plastic stream quality?
I can maybe start answering, but Jayasina maybe has a better answer. First of all, I'm not at all a specialist of bacteriostatic additives, but I can imagine it could play a role in the biodegradability of the materials, especially because much biodegradable bio-based plastics are said to be compostable or biodegradable in controlled conditions. But in the end, we see that sometimes the kinetic principle of biodegradation is not enough, or it's too slow to biodegrade in at the same speed as the organic waste. So if it's about controlling the biodegradation of those kind of materials, and I would say yes, it would be interesting, and maybe it would also be something to be discussed for the update of new biodegradation standards or new biodegradability certificates. So that is what I would say.
Okay, thank you. Maybe we move then to the next questions. Multi-layer materials. So this is maybe to Arnold as well. So do you see that there is a possibility to separate the multi-layer plastic layers?
So it is possible.
Is it practical? So yeah.
I could give maybe I can start with the plastic multi-layers, but also maybe our colleagues from the fiber-based packaging can also answer. We have, for example, just a project which just finished, which is called Terminus, in which we have learned how to integrate enzymes into multi-layers and to selectively biodegrade some layers so that we can delaminate the multi-layers, and it works. At semi-industrial scale, so that's very good. But again, to do that at higher scale, it would need some investments for the sorting centers, for the recycling centers. So we need to look very carefully at the economic balance of the process. Technologies work, but we know that the economic balance of the sorting and recycling industry is very tight. So each time we propose them something new, it's always a question of profitability that will make give a green light or a red line, or a green light, red light, or sometimes orange light. That's very important to say, I think.
Yes. Okay, I'm sorry, I a little bit mixed up. This was a little bit more question to Ulrich, but thank you for explaining also the situation with the plastics. So this is about the fiber-based material where you have as a multi-layer plastics.
Yes. So it's a bit similar answer than that I gave already earlier. So it depends, of course, also on the influence on the quality on the paper. So, but of course, for the paper recycling, what happens is that of course this goes to the paper recycling. And so it's a sorting plant, and then there is a stream that goes to the paper mill, stock preparation. So where basically this material is repulped, and it will come in a lot of with different applications. So the issue is then you will not have in the recycling plant only cups with a certain technology in the layer, but basically you extract the fibers, and then you have the reject, and that reject is of course a mix. And I think that is the issue, how you can move them from incineration of that reject, which is what happens normally today, into higher value applications, because it's a mix of different applications. And I think the recyclability of that in outside then the paper industry needs to be further looked at, and indeed there is economic considerations for this, because it's a mix of different technologies. But for the paper recycling, of course, it is possible, but also providing not only a certain percentage, here it's 10%, they are generally, but then also the quality parameters. Does it harm? Is it adding stickies to the paper? Does it leave anything into the water cycle of the paper industry and mill and so forth? So it's not just that threshold.
Yes, and maybe the 10% is not the limit, so that in a way there is a different category of recycling so that it can be higher, maybe 20% amount that is reject, and it's still considered as recyclable.
Yes, so in terms of fiber yield, let's say often 20% is looked at something where below, then it's not recyclable in a standard paper mill.
No, I mean that the reject rate is 20%, so it's still considered as recyclable.
The forever green recyclability evaluation protocol, the reject rate is indeed max 20%. Below that, it would not be considered any more recyclable in standard equipment.
Yes.
Then it would have to move to a special recycling plant that can deal with packaging, like for example, beverage cartons, etc.
Okay. Then if we move over. There's a questions about the practical things. So yes, it's recorded. So you will get an access to the presentation after the webinar. And then there's a question about how do you see paper complexes? Yeah, it was already discussed. This one as well. Yes. General question.
This one we did it. Yeah.
Yes. Do we still have some questions?
This one. Do we see a demo?
Do we see a demand for end users to increase the fraction of paper in a paper-based complex that will justify the use of complex barrier material? Yes, that's the question. Who would like to answer? Nobody interested to pick up? It's a challenging question. So what do you mean that increase the fraction of paper in a?
I can try to answer it. So I think it is the demand comes, of course. So for an end user, meaning of course packaging producers and packaging producers. So it's not customers, let's say in the supermarket. I think it's end users in the meaning of businesses, so packaging producers. And so the demand comes, of course, from the recyclability considerations. I think so. So how and so there we see, of course, a trend, but maybe others can also confirm or contradict to look at how can we reach the same functionality, but with an increase, with basically keeping this increased share of fibers to reach indeed then the yield in the recycling plant, so that it is material that can actually be recycled back to paper. So it's more about decreasing the non-paper components rather than increasing the fiber components.
Yes, so in a way, paper for recycling is not just fibers, but there are also some other material which can be taken back to the paper mill. So like pigments are sometimes also included there and so on. So, okay, we still have some.
Just to add something to the answer, I agree there is a high demand for fiber-based packaging. It's probably about recycling. I think it's also because the consumers prefer a better idea of paper packaging than plastic packaging. So I think that's also one reason why the business is putting on the market maybe or increasing their demand for fiber-based packaging. But it's true that many solutions are not 100% fiber-based, and there are other things which are going to do that with recycling plants like plastics, and that would be a very nice project to settle between the fiber-based industry and the plastics industry, because we know there is loads of plastics finishing or in the paper recycling plants that need also to be recycled. So if we want to act together for the best, for the consumers, for the environment, that would be a very nice project to work on.
Okay, it's ideas about demand for new projects and calls for the future. So, okay, you will have the access to the presentation of the web, yes. Okay. Yes. Okay. Is there any questions here? Ulrich?
Yeah, thank you. I have a question to the representative from the JRC who presented the study about Automotive, because indeed I think it was very nice to see that you highlighted this. I think you formulated as cannibalization of basically buying then recycled materials that are actually from other sectors. And so we see the repercussions of this also in the packaging debate today, where then definitions are introduced to protect other sectors and protect themselves from this cannibalization. And that has then an effect on paper, where we actually are having a closed material loop. So I think it's a very important aspect. But I also wanted to ask, why do you see the risk that if you don't consider pre-consumer material, that then there is no market for this pre-consumer material? Or do you then actually rely on other sectors outside of automotive to use the pre-consumer plastic material as well? So that would have been my question.
Yeah. So unfortunately, I think that our presenter has already gone. He had an email that chat message that he had another meeting. So, but this is a important question that in a way, and maybe this closed loop would be somehow the answer that from the plastics from the automotive industry would go to as a closed loop, but we will see how it develops. There's quite a lot of work to do in that area still. But thank you for your important question. So, but there's probably not a right answer yet. Any other questions? Not in an audience. So then I think that we are on time to closing the Zoom webinar. And thank you for everyone joining here in Brussels, and then also in Zoom. And you can find then later on the presentation and recording on our web pages. And we will have I would like to thank all the speakers, especially for contributing to this webinar. Thank you.